Inequalities. Inequality is a mathematical statement that compares two expressions. Its symbols are less than or equals to, greater than or equals to. So these are the four symbols of inequality. Now in inequality, we have some rules. Rule number 1. If any value x is added to or subtracted from both sides of an inequality, the sign of the inequality remains the same. So for example, if a is less than b, then a plus x is also less than b plus x. So if we are adding or subtracting, the sign remains the same. This is less than. So when we add a number to a and add that same number to b, the sign will not change. Now let's take a number. Consider minus 4, which is actually less than 5. Okay, so let's add a number to both minus 4 and 5, the same number. Let's use 2 minus 4 plus 2. It will be less than 5 plus 2. Now let's see. Minus 4 plus 2, that is minus 2. Is it not less than 7? Of course, it is less than 7. So by the time we decide to add the same number to the both sides of an equality sign, either we add or subtract, the sign remains the same. The sign will not change. Rule number 2. If any positive value x multiply or divide both sides of an inequality, the inequality sign remains unchanged. For example, if a is greater than b, then ax will be greater than bx. So by the time we multiply or divide a or b with a positive, take note, it must be a positive number, x. Then the sign will not change at all. So let's consider an example. 4 is greater than 3. So by the time we multiply 4 and 3 with the same number, let's see if the signs will remain. Let's multiply 4 times 5. Will it be greater than 3 times 5? 4 times 5 is 20, and 3 times 5 is 15. Of course, 20 is greater than 15, so the sign is true. So what if we decide to divide? Now consider another example, which is 6 less than 8. Now if we decide to divide both number by 2, will this sign hold? This is 3 is less than 4, which is also correct. So if we're multiplying or dividing by a positive number, the signs remain the same. Now let's proceed to the third rule. If any negative value x multiply or divide both sides of an inequality, the inequality sign is reversed. The sign will change because it is a negative number that we use to multiply or divide. So it implies that if a is less than b, then a into minus x will be greater than b into minus x. So when we are multiplying or dividing by a negative value, the signs will reverse. So if it's less than, it becomes greater than. Assuming it was greater than, it becomes less than. If it's less than or equals to, it becomes greater than or equals to. And if it's greater than or equals to, it becomes less than or equals to here. So the sign will reverse. So let's take an example. Now consider that minus 6 is less than 30. So what if we decide to divide minus 6 and 30 by a negative number? For example, let's divide it with minus 3. 30 over minus 3. Now minus 3 divided minus 3, that is 2. And 30 divided minus 3 is minus 10. Now, will this less than still hold? Is minus 2 less than minus 10? No, instead minus 2 is greater. than minus 10. So the signs will change. And if we consider another one, let's multiply this one this time. We have that 4 is greater than minus 2. So what if we multiply by a negative number, which is 4 times minus 3? This sign remains. This is minus 2 times minus 3. Now, 4 times minus 3 is minus 12. Minus 2 times 3 is 6. Now remember we're starting from greater. Is minus 12 greater than 6? No. Instead, minus 12 is less than 6. Now let's take some examples. Example 1. Find the solution of the inequality below. 4x plus 3 is less or equals to minus 17. Now we'll do solve inequality as we solve our normal linear equation or quadratic if that is needed, but this looks like a linear equation with the inequality sign. So the first step is to take like terms, which is 4x is less or equals to minus 17. If 3 crosses over, it becomes minus 3. So 4x is less or equals to minus 20. And when we divide both sides by 4, which is positive, the sign remains unchanged. So it becomes x is less or equals to minus 5. And that is the answer. Now, if we're going to draw out our answer, we use number line. Now, we know that in our number line, we have numbers like minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. So these are the numbers in the numbers line. Now, which part of this does this set represent? Point minus 5 is our focal point, which is this point here. This is minus 5. And you know that if you draw your circle on it and the equality sign holds, you are going to shade it. Okay, so if x is less or equals to minus 5, we need those numbers that are smaller than minus 5, and it will go to this direction. So we've just drawn it. It's less. Minus 6, minus 7, minus 8, minus 9, they are less than minus 5. But this value here, minus 4, minus 8, minus 2, minus 1, they are greater than minus 5. Let's move to example 2. In example 2, the equation look like this. Minus 5 is less or equals to 2x minus 1 all over 3, and this is less than 7. So we have to simplify this expression. Well, it's quite easy. We just have to break it into two parts to solve it. We first need to solve this part first, then we'll solve this part. So for the first one, we have that minus 5 is less or equals to 2x minus 1 over 3. So let's leave 7 out of it first. So we need to simplify this. So what will be the first step we can take? Well, we're going to decide to cross multiply or multiply both sides by 3. About the 17. So the point is we will need to eliminate this 3 over here. So to eliminate this 3, you need to multiply both sides by 3. So it becomes 3 into minus 5 is less or equals to 3 into 2x minus 1 all over 3. Of course, this 3 will cancel this 3, and that's the excess of multiplying both sides by 3. So this 3 will cancel this 3, and it's gone out of it, and it is out. So 3 times minus 5, that will give us minus 15. Is less or equals to 2x minus 1. The next step is to take like terms, which are minus 15 and minus 1. So minus 15, if 1 crosses this way, it becomes plus 1. Is less or equals to 2x. Minus 15 plus 1, that is minus 14, is less or equals to 2x. At this point, we divide both sides by 2 in order to eliminate this 2 over here. But take note that we are dividing by a positive number, which is 2. So the sign does not need to change. So 2 will cancel 2. We're left with x here. Then 2 into minus 14 is minus 7. So this implies that minus 7 is less or equals to x. Now, take note of this next step. It is fitting to always write x first before the value. Now, if we're going to write out s first, this sign will change. Now, why will it change? Now, consider this. It is said that 4 is greater than 2. But assuming you want to rewrite this expression writing 2 first, it means that 2 is less than 4. So these two things are just the same thing. By the time you take 2 first, you need to change the sign. It's very important. So if minus 7 is less or equals to x, it implies that x is greater or equals to minus 7. Always remember that you must change the sign. So, for the first part, x is greater or equals to minus 7. Now let's move to the other part of the equation, which is 2x minus 1 all over 3 is less than 7. So, the same way we did the first one, we need to multiply both sides by 3, and that will give us 3 into 2x minus 1 all over 3 is less than 7 times 3. So 3 will cancel 3, obviously. We're left with 2x minus 1 is less than 21. So we take like terms, which is 2x is less than 21 plus 1. 2x is less than 22. And then we divide both sides by 2. 2 will cancel 2. So x is less than 22 divided by 2 is 11. So x is less than 11. So at this point, we need to merge both answers together. Remember the first answer that we have was minus 7 is less than x. And the second answer is x is less than 11. So minus 7 is less or equals to x, while the other one is x is less than 11. So by the time we merge it up, we have that minus 7 is less or equals to x, and it is less than 11. So when we combine those two, it just gives us this. From here, we'll see that minus 7 is less or equals to x is less than 11. And when we try to draw this in our number line, let this point be 0. If here is 0, then minus 7 will be around here, and 11 will be around here. So we're interested in minus 7 and 11. Now, in minus 7 is we have less than or equals to. Because the equality sign, we'll shade it. Then you observe that minus 7 is less or equals to x. Or in other words, x is greater than or equals to minus 7. So those numbers that are bigger than minus 7, which is minus 6, minus 5, minus 4. So we're moving to this direction. And from this other side, we'll draw the circle, and the equality sign does not hold here, and x is less than 11. So x is those numbers like 10, 9, 8, 7, 6, those numbers less than 11. Now I'm not going to shade it because the equality sign is not there. So x is this direction, and they're going to meet. So the number at this range from minus 7 to the very smallest number before 11, like 10.999999, because x did not get to 11. These are the value of x. So that's the solution to number 2. We'll now move on to number 3. Question number 3. We're going to simplify this expression, which is x squared plus 3x is greater than 28. S squared plus 3x is greater than 28. Now this equation is a quadratic equation. So for that reason, we're going to use one of the method of a quadratic equation to solve it. Which method are you best familiar with? Well, I'm going to make use of the quadratic equation to solve this. Now, in the quadratic equation, it has the form that as squared plus bs plus c is equal to 0. And when this is true, then x, which is the root, is equals to minus b plus minus the square root of b squared minus 4ac all over 2a. So we'll make use of this equation to solve this question. But take note that from this question, it's not rearranged. We need this constant c to be at the left-hand side of the equation, not the right-hand side. Okay, so it becomes x squared plus 3x. If we take minus 28 this way, it becomes minus 28 is greater than 0. Now, I want to modify this equation so that it fits with what we have here. And this is what I will do. Let me use greater than 0, the inequality sign. So if I use greater than 0 here, it also implies that I will also use greater here. So I've modified it. Of course, any sign, any symbol you put here, always put it here as y. So if this is true, we have that x is greater than minus b plus minus the square root of b squared minus 4ac all over 2a. But what exactly is a, b, and c? Of course, the coefficient of s squared is a, which is 1. The coefficient of x is b, and those constants is c. So a is 1, b is 3, and c is minus 28. So let's input them into the formula. S is greater down minus b is 3, plus minus the square root of b squared, which is 3 squared, minus 4 times a is 1, times c is minus 28, all over 2 times a. 2 times a is 1. So we're going to simplify this equation down. We have s is greater than minus 3 plus minus the square root of 9 minus 4 times 1 times minus 28. Of course, minus times minus is plus. So 4 times 28 is 112. All over 2. So this gives us x is greater than minus 3 plus minus the square root of 121 all over 2. We stop at s is greater than minus 3 plus minus the square root of 121 over 2. So x is greater than minus 3 plus minus the square root of 121 is 11 over 2. Either x is greater than minus 3 minus 11 over 2, and x is less than minus 3 plus 11 over 2. Is it that is odd, or x is, the sign will change now. If this is greater, it becomes less than minus 3 minus 11 over 2, and x, the sign will also change, is greater than minus 3 plus 11 over 2. So it's either this we hold at this point or this one we hold. So let's work with the first one. In the first one we have that x is greater than minus 3 minus 11, that is minus 14 over 2, and x is less down Minus 3 plus 11, that should give us 8 over 2. So x is greater than minus 7 and x is less than 4. And is this reasonable? S is bigger than minus 7 and S is smaller than 4. Of course it is. It's very possible that S can be bigger than minus 7 and smaller than 4. But this other expression here, will this one be reasonable? Now let's check. In the other expression, we have that x is less than minus 3 minus 11, that's minus 14. Minus 14 over 2 is minus 7, and x is greater than minus 3 plus 11 is 8 over 2, 4. Now, does this one seem reasonable? S is bigger than 4, but the same x is smaller than 7. Now, values bigger than 4 are 5, 6, 7, 8, 9, 10. Now, none of those numbers can be smaller than 7. So this one does not make sense. So this one here does not make sense. It means that we're going to work with this first assumption here, which is s is bigger than minus 7 and s is less than 4. And that will be the answer, that x is bigger than minus 7, x is less than 4. And when we merge both answers together, we have that minus 7, we're going to reverse this one, is smaller than x, and this is smaller than 4. If we draw it in our number line, this is 0, this part is minus 7, and this part of it is 4. So there's no equality sign here on both sides, so don't shade any of them. So s is bigger than minus 7, so is this region of it, and s is smaller than 4. So these values from minus 7 to 4 are the values that satisfy the inequality. We'll move further to example 4. In example 4, we're going to simplify the absolute value of 4x minus 5, and this is less or equals to 7. Now, why dealing with absolute value is quite easy. For example, if the absolute value of a is less than 5, if I was to simplify this expression, it implies that minus 5 is less than a less than 5. So these two expressions are the same. We expand this absolute value to have an expression like this. So if we're going to use this principle to solve this equation, we have that minus 7 is less or equals to 4x minus 5 is less or equals to 7. So just like the way we solved the previous example, before this we solve two parts of it first, and then we solve the other part of it. So for the first part, we have that minus 7 is less or equals to 4x minus 5. So the next step is to take like terms, which is minus 7 plus 5 is less or equals to 4x. Minus 7 plus 5 is minus 2 is less or equals to 4x. By the time we divide both sides by 4, we have that minus 1 over 2 is less or equals to x. So for the first part of the equation, minus 1 over 2 is less or equals to x. So for the other part of the equation, we have that 4x minus 5 is less or equals to 7. That is 4x minus 5 is less or equals to 7. So by the time we take like terms, 4x is less or equals to 7 plus 5. So 4x is less or equals to 12. We divide both sides by 4. 4 comes to 4x is less or equals to 3. So the two answers we have for x is minus 1 over 2 is less or equals to x, and x is less or equals to 3. So by the time we merge both together, we have the minus 1 over 2 is less or equals to x and this is less or equals to 3. So by the time we draw our answer in the number line, so we have minus 1 over 2 here, and we have 3 over here. So we draw the circle. Of course, equalities appear in both, so just shade both of the circles to show that it gets to that very point. So this part of 8 is greater than x, and this part of 8 is less than s. We'll merge them together. This is how we represent it in the number line. So at this point, if you want to learn more about inequality, if you have any problem in inequality, just forward it to me on WhatsApp. Meanwhile, subscribe to my channel, like and share this video. I will see you in my next video. Bye.